Okay, so when you have such a one, it's up to you to choose whether you should use the left hand side or the right hand side. So in a case where you have something like sine x on one side, it's better to use the other side, which is a bit more complicated. You simplify it and then you obtain this. I'm not saying you can't use this side, I'm just saying it's much easier to use the other side, which is more complicated. So I'll use this side. I think this looks easy. Let's see. So cot squared theta by definition is the reciprocal of tan. So this is the same as cos squared theta over sine squared theta multiplied by sec squared theta is the same as 1 over cos squared theta. So I can even see the answer for even do much. Okay, so you can cancel this with that. So this one will give you 1 over sine squared theta. Now sine squared theta is the same as cosec squared theta. So if you have your cover page right now, there is an identity which has this one here. Assuming you don't have that, you can just use this same identity. This one must always be in your head. So sine squared theta plus cos squared theta is equal to 1. So you are trying to obtain an expression for this. Yes, so you can use this to obtain the identity for this. To do that, you know that this is 1 over sine theta. So you can just divide each of these terms by sine squared theta by sine squared theta by sine squared theta. As you can see, this is the same as that, which is cosec. So sine squared theta into sine squared theta is simply a 1. And then cos squared theta divided by sine squared theta, by definition, this is cot squared theta. Then 1 over sine squared theta, this is cosec squared theta, which is what we are looking for. So where you have a cosec here, remember we ended there. Where you have cosec theta, you can always put this because this is the value of cosec. So this will be 1 plus cot squared theta, and this proves the identity. As you can see, this is what we have on the right hand side. So to use this side, if at all you decided to use this side, doesn't look like a good idea though. Let's give it a try anyway. So this one will be 1 plus cot squared theta. So you can write this as cos squared theta over sine squared theta. When you get your common denominator there, which is this, you have, if you want to put the 1 there, you can say 1 into sine squared theta is sine squared theta multiplied by 1. This will be sine squared theta, then plus sine squared theta into sine squared theta is just a 1 multiplied by cos squared theta is cos squared theta. So as you can see from the basic identity, this one is 1 over sine squared theta. Okay, this doesn't look good, but if you want to continue with this, there is this trick we do usually at a more advanced level. So where instead of having 1 over sine theta, remember what you're looking for is cot theta, which is like cos squared theta over sine squared theta multiplied by 1 over cos squared theta, if I was to write this like this. So we only have this part here, we don't have the rest of this part. But you know that if you were to write this as 1 over sine squared theta multiplied by cos squared theta, cos squared theta, this is like a 1. So we normally multiply by what some people call a super 1. So you can multiply this by cos squared theta over cos squared theta. So the special part about this is it doesn't change anything because this is just the 1. You are dividing and multiplying by the same cos squared theta. So it's the same as multiplying by cos theta, by 1, which won't change a thing. So now we can multiply this by that. So it's like saying adding and subtracting. I don't know if you've heard of that statement before. So this one will be cot squared theta, and then this one will be sec squared theta, which proves the identity. So I think using this side here, the left hand side, is much better in such a case.